Imagine discovering an ancient artifact and wishing you could know its exact age, not just a rough estimate. It is a fundamental quest in archaeology, turning scientific measurement into a precise historical understanding. Radiocarbon dates get calibrated using a curve to convert a sample's raw radiocarbon age into a more accurate calendar age range. The raw age, which is based on the decay of carbon-14, does not directly correspond to calendar years because the concentration of carbon-14 in the atmosphere has varied over time. The core reason for calibration lies in these atmospheric fluctuations. Factors like changes in the Earth's magnetic field, variations in solar activity, and even the burning of fossil fuels in modern times have altered the amount of carbon-14 available for living organisms to absorb. Without accounting for these changes, a raw radiocarbon age could be significantly different from the true calendar age. To calibrate, scientists first measure the remaining carbon-14 in an archaeological sample to determine its raw radiocarbon age, often expressed in radiocarbon years before present. Then, they plot this raw age onto a global calibration curve. This curve is a detailed graph that maps known calendar ages to their corresponding radiocarbon ages, effectively acting as a translation tool between the two dating systems. The calibration curve is meticulously constructed from samples that can be precisely dated by other independent methods. Tree rings, for instance, provide an annual growth record stretching back thousands of years. By measuring the carbon-14 in specific tree rings, scientists can create a reliable timeline, offering a historical record of atmospheric carbon-14 concentrations that informs the curve. Once the raw radiocarbon age is plotted on the curve's shape dictates the resulting calendar age range. Because the curve is not a straight line, a single raw radiocarbon age might intersect the curve at multiple points or span a wider section, resulting in an output of not just one date, but a probability distribution of calendar dates, indicating the likelihood of the sample originating within certain timeframes. This process transforms a scientific measurement into a nuanced and historically meaningful timeframe for our understanding of the past.